Hello everyone, thanks for coming today. In this session we are going to talk about a rather special topic. When building a platform, a developer platform, we usually think about things like availability, scalability, user experience, and things like this. But we rarely think about testability. So today we'll talk about platforms, of course, but most importantly, we'll see how to apply test-driven development to platform engineering, if we can. And here's what to expect during this session. We will first build the platform without any test. We'll run it, and surprisingly, something is probably going to go wrong. Second, we'll introduce test-driven development. We'll start from scratch again and rebuild the same platform. This time, writing tests before writing the different components of the platform, and we will ensure that the platform contracts remain valid within every single change. And third, we'll see how this test can be automated, executed automatically, both locally by a platform engineer during development and by developer teams, or in a continuous integration pipeline on a continuous integration platform. For this example, it will be GitHub. So, yes, before diving into the main content, let's start with introductions. So I'll give the floor first to Sara.
Hi.
Introduce yourself.
Hi everyone, I'm Sara Qasmi. I'm a platform engineer working at Entity Data.
So welcome.
Thank you.
I'm Charles-Edouard Brétéché, the Sara co-speaker. I work at Nirmata. I'm a senior software engineer, and I mostly work on Kubernetes and open source projects in the Kubernetes organization. So now the introductions are done. Sara, our favorite platform engineer today, can you present the need and the platform we'll be building?
Yeah, sure. So our goal is simple. We want to run Drupal application in our platform. We have two teams involved here. A platform team guaranteeing the fundamentals, Kubernetes cluster, database services, for example, taking care of the networking, CI/CD, etc. And we have a development team that needs a functioning environment to run the Drupal application. So on the surface, things seems pretty obvious, and every team has its own scope and things are clear, but what could go wrong in this scenario?
Let's see.
Let's see. So our stack is very simple. We have Kubernetes cluster, ArgoCD for GitOps-driven continuous deployment, and Crossplane. This is the component we are using to provide infrastructure services like databases. For example, our Drupal application needs a database, so we need to provide this service to our consumers. Let's build this platform, Charles-Edouard.
Okay, let's build it. Let's try to build it.
Yeah.
So show me some Drupal application now.
Yes.
I want to see a Drupal website.
We have a repository, our GitOps repository, that describes the different components of our platform. Nothing new for you. So we are going to bootstrap a new cluster in our local environment and run ArgoCD in this cluster, and later try to get the different components of the platform running in this environment. So we are using DevOps to set up the platform. Sorry, I cannot write and speak in. Okay, so here.
I think we have a previous cluster installed,
okay,
so let's just delete everything and start again from scratch.
Yeah, sorry. This was from our previous dry run.
Okay, so the setup should work this time.
So here we have the cluster, the kind cluster running inside our local environments. It will install ArgoCD and port forward to be able to access the UI and see what we have in this environment. ArgoCD is connected to our GitOps repository, which describes the different components we want to deploy. We have two teams, as we told you before. So the platform team and the development team. In the platform folder, we have the different components we want to deploy as platform engineers want to. So we have Crossplane here, the controller and different CRDs we need. We have our definition of the composition of the database. And we are using Helm provider to implement this composition. So this is the platform side. At the development team side, we have a Drupal application that we want to deploy in this environment. So let's switch back to our terminal and see if, ArgoCD is getting deployed right now. The cluster is up and ready, and let's wait for a few seconds for ArgoCD to get up.
Can you show us how the dev team is going to get a database actually?
Exactly. So our implementation is using Crossplane, which means that we are trying to hide the implementation, the implementation detail of the database service. Crossplane provides this a way to create an interface or contract between the platform components and the applications that are consuming the platform. For example, here we have a Drupal application that needs a database, a MariaDB database. So we have the interface or the contract that defines the inputs and the outputs, and the implementation that can be implemented by platform engineers. This approach gives more freedom to our platform engineers to change the implementation without impacting the users of the platform. The implementation will not impact the contract or the interface.
Okay, let's see if our ArgoCD is up and running.
Exactly. So here we have ArgoCD still trying to run. Yeah, so now we have ArgoCD running. Let's connect to the UI and see. Yeah, this one.
I think we have problem with the network.
I know. The port forward is still not yet there. Yeah. So just give it a few seconds.
Our pod's running?
Yes.
Oh yeah, they are starting.
Yeah, just.
It's coming.
Yeah, needs some time. So now it's there. Let's check again ArgoCD. We have our ArgoCD. Thank you. Thank you. So the ArgoCD is here, but we don't have any components of the platform, or what we described in this repository, because we did not bootstrap the GitOps repository. So let's do it.
Now the interesting things are going to start.
Exactly. So the previous part was pretty obvious for everyone, I think. So here we are going to see ArgoCD synchronizing the different things we have in our GitOps repository, the remote repository we were describing. We have the Crossplane controller itself. We have the composition, the definition of our composition, the Helm provider that we are using to implement the database, which means that our database will run inside the cluster. And we have the Drupal application that needs access to this database and request the service. And the database, the Drupal application is requesting the service via specific resource that we provided with this composition called MariaDB instance. So we can see here that the resource is part of. Is it big for you guys? I think, yeah, no, it should be. Yeah. So here we have the MariaDB instance. This is what represents the interface that we were talking about. The developers can request databases through these resources and include them in their application Helm charts. This will produce a creation of proper database with the different dependencies like secrets, services, etc., to make sure that the application can connect to the database.
Okay, so this production cluster is running on my laptop.
Exactly.
But it's synchronizing against a remote repository that is in GitHub.
Exactly.
And can you show us how a MariaDB instance looks like?
Yeah, sure.
How a developer can request a MariaDB instance without a Jira ticket, for example.
It's very important. So let's go back to the GitOps repository. In this repository, we have different manifests we are trying to deploy in our cluster. It's what ArgoCD is trying to synchronize right now. And we have the DB instance. This is what they provide, the developers need to provide to request a database. And the implementation is guaranteed by the composition that the platform engineers created on the other side. So this is the interface or the contract that we have with our consumers.
If you want a database, you just create a resource MariaDB instance.
Exactly.
And the platform team worked to create the corresponding database. And what do you have in output?
Yes. So the composition itself is when you request a database using this MariaDB instance resource, you have the implementation behind is a composition, Crossplane composition that will use the Helm provider to install the database via the Helm chart, and also it produces a secret that contains the password to connect to this database. So the instance will be, sorry, I think now it's bigger for you.
I think.
So yeah. The secret itself is what the application will use to access the database, right? So this is the output of the composition, and if we break for any reason this output, this will break the application running inside our cluster. So let's go back to our ArgoCD cluster.
So basically you have an endpoint and the secret containing the password to access the database.
Exactly. Okay. So what we see here in this view, we have the MariaDB instance, the secret, and the instance, the database pod is running behind the scene here. And the Drupal app is trying to connect to the database to start the pod, okay?
Okay.
So let's try to break this and see how we can break this application.
Okay, I think the network is not that good, so it has trouble pulling the image.
Yeah. So,
but we get the idea.
Yes, exactly. So here let's try to change the name of the service that we are providing in this composition. This should be a change on the platform side, which means that our platform engineers, for example, for some reason decide to rename this secret differently without informing the developers. And this, in this situation, will result the creation of a new composition revision, which will be used for future databases we create in this cluster. So the new databases will be created with this secret named DrupalDB and not DrupalDB connection. But our application itself is expecting a DrupalDB connection, right? So if we don't inform our developers that the name changed, this could break their applications without any
Okay, so if you push that without any test,
yes,
you're telling me that it will break the Drupal application. The production Drupal application will stop working?
Exactly.
Oh. Yeah, something can go wrong, actually.
Hit push, okay.
I think
yeah, sorry.
Yeah. Git commits.
Thank you. Okay, push.
Push on master.
Yeah. So we are pushing on master branch.
Best practice ever.
Yeah, exactly. So let's see how this will break our application. So here, ArgoCD is synchronizing and it's creating a new revision of our composition, which means that if we create a new database right now, it will appear with a different name in terms of service. So for some reason, our developers can decide, or by mistake, to delete the Drupal instance. Okay.
Okay.
Oh. So here, ArgoCD will synchronize again and create a new secret, right? So our application is expecting a Drupal DB connection, and we have Drupal DB. So let's try, for example, to scale it up and try to have a second replica of this pod. Let's see how this will be done here.
Let's break it.
Let's push.
So what?
So the first pod is still trying to synchronize. But here we are going to have like a pretty obvious error. We don't have the secret. We are expecting database DB connection, but we don't have it. The previous one does not have this error, this issue. Sorry,
it has
but
it because it took too much time
to pull the image and get the pod. But you get the idea, right? So now, can we do things better?
We can try.
Yeah.
I can't guarantee that we can, but we can try at least. So yeah, there's a couple of things that are what, oh yeah. So we built it, we used it, we broke it, and we see the contract between the dev team and the platform team. So now, the question is, can we do TDD with platform engineering? And that's exactly the kind of issues we wanted to show. When building a platform without tests, error will inevitably occur. And they can have unexpected consequences. Like in this example, a simple secret name change doesn't break right away. It breaks when the application scales. So you don't see it. You see it maybe 2 hours later. And connecting the dots is not always easy. There's a way to reduce this trust and maintain confidence in our changes. It's test-driven development. So in the next part of this session, we'll see how to rebuild this same platform using TDD from the start so that the contracts between the platform team and the developers team remain valid. And such incidents are much less likely to happen. So let's try that, and maybe we can do that. We'll start by adding tests. So we'll do that. I think I can make it bigger.
Yes.
We have a couple of tests. This time we will run tests.
So you are going to add tests as part of the CI pipeline of this? Because right now we don't have any pipeline for this repository.
The main difference is that we are not going to push on master. So let's test platform. Let's create a branch. Hopefully we can do that. We can add platform tests and push that. Yeah, of course, the branch doesn't exist. If we go back to our repository, this time we have a pull request open with platform tests added. Remember that on the main branch, we didn't fix the wrong secret name. Yeah. So we open a pull request that adds a test, but this test will hopefully break because the secret is not the correct one. So
the test you are adding here is checking the secrets, the name of the secrets. This is the dependency we have here, and we want to make sure that it's always the same. We are always using the same name.
So this is a very simple workflow. We are installing a couple of tools. We are provisioning a local cluster. So this cluster is running on the GitHub runner. We are going to install Helm, Crossplane, and everything that our platform team built. And then finally, we are going to run the platform tests. Those platform tests are written using Chainsaw, the Kyverno Chainsaw tool developed by the Kyverno team. And it allows us to simply call Chainsaw test, giving it a folder. Chainsaw will discover the different tests we have in this folder in a recursive manner. And this will do the following. A Chainsaw test is just a sequence of steps. Each step can contain different actions. So in this case, we have a single step. We could have split it into multiple steps, but finally, it's one step and multiple actions. So the first one is going to create a MariaDB instance, the same that we do with the GitOps approach, and the same thing that ArgoCD does. We will do that in an ephemeral namespace. So at the end, the ephemeral namespace that lies only for the time of the test will be deleted. Of course, Chainsaw will also delete resources that it created in opposite order. Then we will first assert that the MariaDB instance becomes ready. And after that, we will check that we have a secret called Drupal DB connection, and that we have a field called DB password that has a positive length. So if we look at what happens in the CI, we can see that it created the MariaDB instance in the ephemeral namespace.
Can you see it from the back? Okay.
Then it asserted that the instance becomes ready, and it was done. And now it's trying to assert that the secret, Drupal DBCon, exists and has the expected properties. And we can see that it didn't find the secret. So the test detected that we broke the contract we expect, the dev team expects.
Okay. So how can we fix it, Charles-Edouard?
Now, the test is ready.
Yeah.
And the PR should not be merged. And it's not fixed on our prod cluster yet.
Yeah.
So, of course, fixing it is obvious. We just have to put the correct name. So we can push that.
So by pushing this, it will run another test, provision a new cluster, and try to create the resource and assert that the secret exists.
Yeah, so this time, the test will be run again. Now, this test is running in our CI, but we can completely run that locally. So we have the test cluster. The prod cluster is running on my machine, so I can definitely invoke Chainsaw here and see if the test will work this time. So it's not a tool specifically designed to run in CI. It can run locally in CI pipelines. It's not a tool that creates clusters, so you can run it against any remote cluster, an EKS cluster, anything. Actually, it's not specific to any Kubernetes distribution, but Chainsaw will not create clusters for you. So you have a cluster, you run tests against it. So hopefully, if our fix was good, it should work.
Let's check the CI.
We can check the CI. I think the CI takes a bit more time than running it locally. And finally, it's not just reserved to platform engineering teams. So yeah, the MariaDB became ready. Now it's going to check the secret. We have another test that runs for the application too. So we create a MariaDB instance. We wait, the instance becomes ready, and you can run a script. So in this case, we can install the application on the ephemeral cluster and make sure that pods come up correctly. So the resource is still not found. And you know why? Because it's on the remote cluster, and the remote cluster is always synchronizing against main. So it's a good sign that it fails here.
Exactly. Did you get it, guys? Because here we are trying to run this test against a live cluster that is synchronizing the main branch, and we made our changes on the different branch, which means that it's not, cannot work.
The network doesn't help today.
Yes.
That's a real demo.
Yeah.
But yeah, we have one pod up and another one down. So that's what we wanted to have in the first place. Then, now we can see that everything worked.
Yeah.
The secret was found. The assertion was validated. And then we can safely merge our PR. Now, if we go back to ArgoCD, we can quickly sync up our Crossplane application, I guess. Yeah. Maybe it was already, it was already synced.
Yes.
We can drop the database again.
Yeah. It's not the best way to do this,
so,
but
again, best practice. Yeah. Deleting databases in production, we all do that. And then this time we have the correct secret, so pods should start becoming green again. So yeah, let's delete it. Anyway, we have the ID. So yes, we demonstrated that TDD can be done. You can write the test first, make test pass second, and finally, the key takeaways from this presentation, because we have only 2 minutes left, is that testability is essential, that TDD is not reserved to dev teams, but can work for platforms too, if you have the right tool. In this situation, Kubernetes Chainsaw can definitely help, because it's purely declarative, so you don't have to be an engineer to write a test. You don't have to write Golang code or anything complex that requires programming language knowledge, so just declarative. Mm-hmm. And yeah, it brings confidence in your deployments. So yeah.
Now the platform team and development teams can coexist in a better way.
Hopefully. If you want to learn more, you can go to GitHub. We have a complete documentation. We have a video that was recorded by Viktor presenting Chainsaw. So it's a very, very, very good introduction to the tool. And yes, thanks for coming.
Yeah. Do you have questions?
If you have questions, we have 1 minute.
Yeah, quickly.
But we stay, yeah. Thank you.